This is scientific notation part 2. If you did not watch part 1, please go back and do so because I go over what standard form, what does scientific notation look like, and I also go over exponent rules. Okay, so we left off at this problem with the last video, and the problem says, hey, write this number 67,200 in scientific notation. All right, so again, remember scientific notation is a times 10 raised to the nth power, okay? So first things first, we got to write 67,200 with a decimal. So I'm going to put the decimal after the 200, okay? Now, I have to move this decimal. Oops, I don't know why it did that, but let's fix that. I'm going to do that again. So I'm going to move the decimal so it's a value, or A. I'm trying to find A. So A has to be a value between 1 and 9. So I'm going to write this up as 6.72. Okay? Now notice that I moved 1, 2, 3, 4 places. So this becomes times 10 to the... Now I'm going to use a positive exponent because my original value was a large number. Okay? 67,200 is a big number. So again, when you're writing something from standard form to scientific notation, you have to be able to check it. You know, so if I check this, 6.72 times 10 to the 4th, I'm going to take my decimal place to the right because the exponent is positive, thus making it a bigger number. So if it's a big number, you're going to use a positive exponent most of the time. Okay? So let's look at this next one. Write this number in appropriate scientific notation. Well, the problem with it now is 8,700 is not a value between 1 and 10. So let's deal with that. 8,700. Okay, so 8,700, to make it a value between 1 and 10, or to rewrite this in scientific notation, we are going to take the decimal and place it between the 8 and the 7. Okay? Now, in order for me to get that decimal, I had to take the decimal and move it 3 places. Since my original number is large, what I'm going to do is I'm going to write that out with a positive exponent. So I move 3 places, it's 10 to the positive 3. Okay, now I'm done rewriting 8,700 in scientific notation. However, I have to do one more step. Now we have to take care of the 10 to the 6th that was there before. And I'm going to highlight that in pink. This, right? We can't just forget about it. So what we're going to do is we're going to kind of merge the two together. Okay, so I have 8.7 times 10 to the 3rd times 10 to the 6th. Now here is where we're going to use those exponent rules we learned about in the last video. When the bases are the same, which they are, both are base 10, we're going to add the exponents values together. So this becomes 8.7 times 10 to the 3 plus 6. So that's 8.7 times 10 to the 9th is going to be my answer. Okay? Okay, so let's look at this next number. Rewrite this number in appropriate scientific notation. Again, this is going to be a two-stepper because the first thing is that value 0.0098 is not a value between 1 and 9. So I have to make it that way. In order to make it that way, I have to move the decimal 3 places to get 9.8 times 10 to the... The original value, 0.0098, is a small number. So I know I have to use a negative exponent, and I moved that decimal 1, 2, 3, 4 places. So 9.8 times 10 to the negative fourth. Okay, so I took care of step 1. I took care of this value here. So this is all I've done. So the second step is we're going to merge the rest of it together. So 9.8 times 10 to the negative fourth times 10 to the negative fourth. So that value, 10 to the negative fourth, the second one, came from this part of the equation. Okay, now we use our exponent rules. 9.8 times 10 to the, when the bases are the same, which they are, you add the exponents together. Okay, so negative 4 plus negative 4 will give me negative 8. So this becomes 9.8 times 10 to the negative 8th power. Okay, so when you do these types of problems where the number is not in scientific notation, you have to deal with that first part. Make a value between 1 and 9. Then merge that second part together. Okay, so two-step process. Okay, let's look at the next problem. Multiply and write your answer in scientific notation. So we have 6.4 times 10 to the negative 41st power times 1.2 times 10 to the third. Okay, what you can do with this is we can take the a values and we can multiply them together, and then we can multiply the base 10 values together as well. Okay, so let's see what this looks like. I'm going to take the a values. Remember, a is a value in front of the 10 to raise the whatever, and it has to be a value between 1 and 9. So I'm going to take 6.4 and I'm going to multiply that by 1.2. So I'm going to put those together, times, and now I'm going to put the base 10s together. So 10 to the negative 41 times 10 to the third. Okay, so all I'm doing is rearranging this so it's easier for me to multiply it out. Okay, all right, so now your next thing you have to do is we got to multiply 6.4 times 1.2. And when I do that, I get 7.68. Okay, times, now I'm dealing with the 10 raised to the, okay, so 10 raised to negative 41, we have a 3. So again, when the bases are the same, we can add the exponents together. Okay, so I'm going to add negative 41 plus 3. So this becomes 7.68 times 10 raised to the negative 38. Okay, so this is your answer. And by the way, when you do these, check, make sure that that first value is a value between 1 and 9, which 7.68 is, so we're good. So we don't have to do anything else. So let's look at this next one. Multiply and write your answer in scientific notation. We have 8.3 times 10 to the 8th power times 4.5 times 10 to the negative 13th power. Again, let's rearrange it. So I'm going to put 8.3 and I'm going to multiply that by 4.5. And then I'm going to put 10 raised to the 8th times 10 raised to the negative 13th power. So all I did was rearrange it. So rearrange first. Okay, now I need to know what that value is. So let's multiply 8.3 times 4.5. So this becomes 37.35 times 10 to the, now remember bases are the same, so I'm going to add the exponents together. So I'm going to add 8 plus negative 13. So this becomes 37.35 times 10 to the negative 5th power. Okay, this is not in scientific notation. And the reason why it's not in scientific notation is because the a value is too big. Remember, that has to be a value between 1 and 9. So in this case, we have to do that two-step process. One, we're going to write 37.35 in scientific notation. To do that, I have to move the decimals, so it's a value between 3 and 7. So I get 3.735 times 10 to the. Now, since I moved that decimal one place, I know it's going to be a 1. And remember, my original value was a big number. 37.35 is big. So I'm going to use a positive exponent. So 10 to the first power. Okay? All right, so I fixed the first part. Now the second part, I have to merge everything together. So 3.735 times 10 to the first, and then I'm going to merge that with that 10 to the negative 5. So I picked up this value here. Yeah. All right, so we're going to use the exponent rules. So this becomes 3.735 times 10 to the 1 plus a negative 5. So this becomes 3.735 times 10 to the negative 4th power. So again, just be careful with these and make sure that your answer is fully in scientific notation. Okay, let's try the next one. Divide and write your answer in scientific notation. So let's just write this out. So we have 6.3 times 10 to the 12th over 8.4 times 10 to the 3rd. Okay, so we're going to break this up. I'm going to take 6.3 and divide it by 8.4. And then I'm also going to take 10 to the positive 12 over 10 to the 3rd. Okay, so let's go ahead and do it in little pieces. So I'm going to take 6.3. I'm going to divide that by 8.4. And when I do that, I get 0.75. Okay, times. Now I'm going to take care of the exponential part. The bases are the same. So the exponent rules say when we're dividing these two, I have to subtract the numerator's exponent minus the denominator's exponent. So this becomes 10 raised to the 9th power. Okay, and this is not in scientific notation, so I have to fix it. So again, I have to fix the first part, 0.75. I gotta move that so the decimal makes this a value between 1 and 9. So I have to move the decimal one place. Okay, so this becomes 7.5 times 10 to the. Because the original value is small, it's 0.75, I'm going to use a negative exponent. So this becomes 7.5 times 10 to the negative 1. Okay, I took care of the first part. Second part, I have to merge everything together. So 7.5 times 10 to the negative 1 times 10 to the 9th. So again, I'm picking up this piece and merging it with what we fixed for the a value. All right, so what does this become? 7.5 times 10 to the negative 1 plus 9. We are adding those exponents together. And when I do that, I get 7.5 times 10 to the 8th power. Okay, that's in scientific notation, so I am done. Okie dokie. The average distance between Earth and Mars is 2.25 times 10 to the 8th kilometers. Write this in standard form. So 2.25 times 10 to the 8th. This is a positive exponent, so I'm going to make a bigger. Okay? So we're going to make a bigger. So 2.25. I'm going to move the decimal to the right. 1, 2, 3, 4, 5, 6, 7, 8. So I need 6 zeros to complete everything out. So this becomes 225 with 6 zeros. So when we write this out, and I put the last comma there in the wrong place. So let me just fix that really quick. There we go. All right, the answer is going to be 225 million is the distance between Earth and Mars. So kilometers. Okay, let's look at the next one. The circumference of the Earth is 4.0 times 10 to the 7th meters. How far in meters will Jules Verne travel if he completes 5 trips around the Earth? Okay, so to figure this out, we're going to multiply everything by 5. Okay? All right, so it's getting multiplied. So let's deal with the 4. So 4.0 times 5 is going to give me 20. Okay. Now, remember, I'm revolving around the Earth 5 times. So this is going to get multiplied. So the 10 to the 7th is going to be multiplied out by 5. Okay? So this becomes 10 to the 35th power. So this becomes 20 times 10 to the 35th power, which is not in scientific notation. So I have to fix it. So fix the 20 first. I'm going to move the decimal so that it falls between the 0 and the 2. So 2.0 times. The original number was big, so we're going to use a positive exponent, and I moved the exponent one place. So 2 times 10 to the first. I fixed the a portion. Now I have to merge the stuff together. So 2.0 times 10 to the first times 10 to the 35th. So this becomes 2.0 times 10 to the 36th power. Okay? All right. All right, so same kind of deal here. It says, what's the length when 30 atoms are strung together? And the original width of the hydrogen atom is 5 times 10 to the negative 8. All right, so we need 30 of these, right? So 30 times 5 times 10 to the negative 8th power. So 30 times 5 is 150. And then we're taking 10 to the negative 8, and we're going to multiply that by 30, because we have 30 of those. So this becomes 10 to the negative 240. Okay? This is not in scientific notation because the 150 is not a value between 1 and 10, so I have to fix it. So we're going to fix the 150 part, the A part. So to do that, I have to move the decimal between the 1 and the 5, so 1.5. I move that decimal 2 places. 150 is a big number, so I'm going to use a positive exponent when I write this out. So this is going to be 1.5 times 10 to the second. And I fixed the A portion. Now we have to merge the two together. So 1.5 times 10 to the second times 10 to the negative 240. So 1.5 times 10, I'm going to add 2 plus negative 24. So this becomes 1.5 times 10 to the negative 22nd power. And this is in millimeters. Okie dokie, that's the end of scientific notation. Woo woo! All right, guys, thanks for watching, and you're done officially with 3.9.